All right, everybody. We're about to get started with our third talk of the day. So if you can take a seat. Let's get started. All right, how's everybody doing? Everybody holding in there? All right, I see plenty of beer still flowing, so this is all very good and natural. We have Sneha and Nikita here. They're going to be talking about making your data lake. And the data lake is something I keep hearing about at my company, but I have no idea how to do it, so I'm very much looking forward to hearing that.
Oh, great. Hi, everybody. I'm Sneha Chaphalkar, and this is Nikita. And today we are presenting a talk on cruising in a data lake from zero to scale. So before we kind of deep dive into this topic, just wanted to share something. When we went through this interesting line of tracks, which are there for this Apache roadshow, the Made in Chicago track felt kind of home, because that is where I think it's a great avenue to share architectures, leveraging some of these open source and Apache projects, and try to build solutions from it. And what a better avenue for kind of sharing that and also learning together. So that's where, so here we are presenting this talk. So in this talk, we hope to kind of share our journey of how we started off from, what was our origin of why we went with this kind of a strategy for analytics. And throughout this, we will be sharing our lessons learned, what kind of techniques can be used. We will be having focus on Apache Spark, and also some of the other Apache projects which we have leveraged in this data lake. And yeah, and then hope to kind of provide some of our lessons learned and our journey through this. So just a quick round of introduction and also to provide a premise. And this is not good.
Okay.
Sorry guys, technical glitch. Okay. So just to do a quick round. So we both work for Here Technologies. So this slide is just to kind of also present where we started our origins for our data lake. Like, why did we have to go for this kind of a strategy? So Here has been in the industry for 30 plus years. We specialize in location technology and also building location platforms. So that is where we have our digital map content and location platform offerings. So with that comes the scale of data, with a lot of data being collected in order to build this map, and also a lot of servings through data as a service offerings through the product lines. So one of the product lines that we have is called Here HD Live Map, and that is where me and Nikita have been building the content management infrastructure, which is for this kind of HD map. And this is nothing but a high definition map in order to provide insights for the car to self-drive. So it is kind of considered as an extended sensor is what it is said, but together with that and the sensors and the ecosystem, the car can take decisions in order to self-drive, and that is where we fit in. So the content management infrastructure which backs this is where me and Nikita have been primarily focusing on for the past few years. So that is where what tells our origins of our data lake. So with that scale, it is a multi-layer product. Enriched from multiple sources. So we get data from different sources. Along with that, we have our own car fleet, which goes around and captures data. So there are different sources. So in order to do that, we also have internally a lot of complex data-driven pipelines, which are running. And these are having a lot of data transformations and data dependencies are going on. So together, that is making it difficult for explorations and correlating the data, especially when you want to do any data-driven decisions, or you want to leverage data in order to kind of drive value or figure out any insights. So we have several valuable feeds within our pipelines. Like we have automated, we have human-in-the-loop feeds, we have sources feeds, which we talked about, and we use a lot of AI within our company in order to kind of do the maps. So that means that we have some predictive and training model feeds, which also come through it. So together, this kind of forms a big mix of complex data processing pipelines. So these pipelines are essentially, there is input from one, which goes goes as an output to the other. The representation on the right is just to kind of show the scale and also to kind of show a direct acyclic graph of relationships going on between data. There are pipelines which output data, which are consumed by the others. This is also a multi-system pipeline, so there might be different teams which are maintaining this. So not necessarily this is all done by one team. So when you have multi-teams, what happens is their teams have different cadences of operation, they have different ways of working, how they want to put their data out. So that makes, again, coming back to our origin of why we went with the data lake kind of necessary in order to kind of drive any insights from this. So a lake range. So we're going to kind of talk in terms of data lake and kind of topics related to it. So lake range means what are we talking about for requirements? So we have 25 plus sub-processing systems. They have their own pipelines going on. The right side again shows a live system which is running with a lot of interactions going on. And this is all data driven, so it's event driven pipelines going on. Some amount of data statistics over here, 90 plus terabytes, a lot of history. If you want to build insights or you want to do any kind of predictive analytics, you need to kind of need historical data in order to kind of figure out the trends. With complex pipelines, the cadence of the data is different. Some might be slow, some might be fast. So in our case also it was the same. We had some which were in hours, some which were in minutes. So the cadences were different. So how do we have different metrics generated from this kind of a leak, or what from this kind of a data? So we need process metrics, we need business metrics. We also need some kind of content metrics to figure out how good is the quality. Are we there yet with certain coverage? So there are different insights which you can get from the data, and this kind of just tells what are our requirements and what are our SLAs that we are conforming to. So now to the topic of what is a data lake, and then we will be deep diving into. So the previous was just a premise to figure out why we have to go with the data lake. So what is a data lake? A data lake is a centralized repository for storage of all relational and non-relational data. One of the key premise of data lake is that if you have some raw data which can generate insights, just bring that data in. In traditional data warehouse kind of schemes, you have a star schema design, you might have heard about that. You're kind of designing some tables, maybe you're aggregating something, adding cumulative additions going on, and then you're kind of putting it for consumption and canned reporting. But the data lake kind of goes with the opposite paradigm is use the data in its raw form and collect as much data as it's possible. So that means that it brings a lot of flexibility. There is no rigid schema design. You just bring in the data, and then it would be schema on the data. So that is one of the kind of big foundations for a data lake, that it's schema on read. So you just bring the data, and then the interpretations and how you would use that data would happen later. So with that, it provides a lot of different use cases. Exploratory analysis, this is essentially your ad hoc analysis, wherein you have your data scientists, your data analysts going in and querying your data, trying to just figure out what can you make sense of this data. Predictive analytics, if you have a lot of historical data, you can get a lot of trends, be it quality, be it content, be it how we are progressing towards our KPIs. A lot of trending could be done and you can predict. And that's where machine learning models could be trained with this data directly from these feeds from the data lake. So both go hand in hand. Batch reporting, needless to say, that comes with any data warehouse. You need to have some batch reports which go to everybody. The last bullet, which is reverse lookup, it's an interesting point. You would not see that come up when you kind of Google or try to find out more about data lakes. The reverse lookup is something which we found really useful in our paradigm, and this is where we are leveraging the data lake to do kind of secondary index lookups. So typically any live system might have some primary identifiers by which you query and pull your content. Over a period of time, we realize that there are different ways by which you want to query this data. Now you have two choices. You go and add that secondary indexes in your systems, but that can make it complicated. You might have to tune your existing systems. Data lake, since it's capturing raw data, you can build secondary reverse lookups very easily. And we've been using it a lot within our pipelines in order to kind of drive downstream based on certain other lookup queries rather than just the primary patterns. So hold on to the heart of this data lake, and we go into the foundation blocks for the data analytics platform. So any platform for data analysis needs a transformer, a storage, and a query engine and aggregator. Transformers are the ones which are actually pushing the data to where you can get analytics from. Storage is where you're actually storing the data. Query engines and aggregators are where you're actually kind of getting some insights from this data. Aggregators are essentially, you might be kind of doing delta analysis, trying to see what changed, or you might be doing some kind of trending to see what changed yesterday. So that kind of aggregations of the data which you're doing. So based on this, we started our journey from mile marker 0. And this is our way of showing where we started in this data lake strategy. So at mile marker 0, this was our strategy. We had earlier data sources which were already present in the organization. They had their own data warehouses, so we had existing data warehouses. We built additional data sources, so we started to have our own data warehouses on top of it. So together there were multiple data warehouses. So what that caused is problems with blending. How do you blend across these different data sources? Maybe you wanted some data and it's not available. So now you have to go and try to reach out to other teams to figure out how you can get their data in. So that kind of caused long cycle times. So these kinds of challenges is what we faced in our mile marker 0 in our quest for meeting our lake range requirements. So then we started to kind of consolidate the data in the data warehouse. Over here we went with Redshift, but there are different data warehouses which can be used. We are completely in cloud, so we leverage the Redshift technology. Hadoop was our way of putting the data in, but we come through transformers and we could use other transformers too. But when we try to consolidate, now you're trying to stress your cluster, now you need experts there, your contention, so going back to your readers and writers paradigm, your query engine was the same and your storage was the same. So now you're trying to kind of write and read patterns are trying to be kind of, there was a contention. So that is where our cluster optimizations resulted in higher costs. So overall, this kind of created a cascading effect, wherein we had to strive a lot in order to make our data warehouse just scale. With so many pipelines running, different cadences, it just couldn't keep up with that speed. And that's where we had to either bring in some kind of expert tuning in order to make this work, or make it more flexible so that we could reduce the cycle times in order to get insights. So that's where our journey started into the actual data lake implementation. And I will hand it over to Nikita to walk us through our mile marker 50, which is our cruising at some optimal speed.
Thank you, Sneha. So how do you actually solve all these issues, right? Microservices. Also true. Obviously, that's you. Actually, you just start maybe playing by the book, right? You just use the tools that we created for ECL, and you're making sure that you're using them in the optimal way. And there's multiple issues can come up, and some of these issues is just getting the right tool for the job, and the second one is using this tool in the right way, because you can do very much different things. And again, what we did, we started using Apache Spark for our ETL jobs, and Parquet and other columnar formats like ORC to make sure that the data that we're capturing is compressed and stored in the right way. We totally teach the data warehouse solutions, right? We just start storing data on a screen and making sure that this data is exposed. And what it gave us is, first of all, easy to produce with Spark SQL and so on, right? So I hope that everyone who's using Spark, like, just to understand. Okay, well, there's some people or okay. No schema maintenance, right? So as you might know, ORC, Parquet allow you to just add columns, and hopefully if you're using right readers or right consumers and query engines, on top of that, it allows you to don't just perform schema maintenance. Second, most important thing, right, is like this was big pain point with Redshift is that our writers and readers are totally separated. Right? The only point of contention now is S3. Right? We were storing data on S3, but you can use anything with it. Right? You can use Google Cloud, Azure, maybe your own like HDFS cluster if you're in this situation. So it's easy to scale each job, right? Teams can now own their own ETL solutions in the sense they don't have to orchestrate anything, right? Which was another major endpoint. There is no competition for resources, and you can see this like little asterisk here. We can talk about that, like the issues, because apparently, but anyways, in general, there is no competition for resources, and buckets are easy to share. Actually, it's if you did your homework right, if you cook your data in the right way with a good compression ratio, it's actually super easy. If no one touches your buckets, they're quite inexpensive to have. So, and that's what I wanted to talk about as a highlight for the transformers. And now maybe we can talk about these guidelines that we utilized in order to produce the data, right? So now let's kind of touch out on like how many different subsystems we have. If you just allow people to do whatever they want, things get messy very quickly. So you need some sort of a guidelines or in terms of the lakes or high big bodies of water, some buoys to navigate this space, right? So first of all, very simple, uniform data, single format, single interface. If you want, like people have to use Coleman formats, period. We're storing our data on S3. Yeah, like no FTP servers, none of that. Like it has to be unified. So everyone knows, like if you work with one data source and one data set from one team, you immediately know how to work with everything else. Frequent incremental updates, right? In terms of like repeating products for autonomous vehicles, and the freshness is important. So if your main pipeline that produces the actual data and publish actual map is working on one schedule, and then you're reporting and some KPIs that you're running after is just lagging behind, that's not a good idea. And we're going to talk later about the frequency of updates, but in general, at least daily we update all our data sources. One table, one source, that's another conclusion that's actually not trivial. People start building out their ETL jobs, and in Spark is so easy to just do a join and combine multiple data sources. But one of the things that we learned, actually, keep it simple. One data has to be derived from one table, one source. Don't try to come up with some very interesting views or extremely rich views. People can do this on their own when they get consuming data, right? And another important thing is consistency and availability first. So for us, again, you've seen like this huge graph that Sneha showed you. Different pieces of the pipeline might be on the different clocks, right? They're working with this different data that they ship forward. It's very important that whenever we provide a report or provide a view of this whole system, that it takes a snapshot of this whole data, right? Because otherwise, when you start joining different tables together, you just can't guarantee results. Right? So, and finally, last but not least, it's security and compliance. People who work with GDPR might understand that it's not a joke. So you have to protect your data. And now, like having all of this stuff, again, you just start exposing your data, but at some point you just realize that you encounter the same patterns, same tables getting created. And for us, we found out that we're mainly working with these three types of tables. One is just the log or history, and earlier on there was talk about pops up, and that's pretty much what it is, right? You're just appending certain messages describing how your data set changes over time. Another one is the latest state, right? So in terms of the map, if my log or history is just basically saying that there's a new sign appeared or there's a road closure over there, then my latest state is just the state of the map right now, where I can pick and choose every single intersection in Chicago or the whole world. And finally, there's lookups and aggregates. Those are very and you can track them over time. And that's in fact that's what we're doing as well. Some interesting aggregates and metrics that you can derive. Now, once you think about it, like how you can produce these three tables, because you're working with the same data set effectively, right? But in reality, it actually reminds you about database engines, right? So you're receiving certain updates to your data set, you're keeping them in your transaction log, if we're talking about relational databases, then you're applying them to your in-memory representation, and then maybe you recalculate something else. You're like changing secondary indices, triggering some stuff, and so on. So that actually sounds very well when you like use this pattern with the Spark jobs. When you're receiving your change set, you're loading or keeping in memory your current state, you're changing it, and you're computing the secondary things like lookups or aggregates. But that's not everything, right? So there's more to it, and there's some principles that I would like to show and share with you. So another thing is that we version everything, right? So in world of map making, you can't actually change usually one thing. It's when you're changing the road or something else, it produces this ripple effect. So when we're talking about that consistency should be your main priority, that's exactly it, right? So everything, like bunch of changes can be bundled together as a transaction or a version, right? And similarly, when we're taking a snapshot, when we're cooking a new version of our report or our data lake, it has versions too. That kind of automatically produces the fact that all our data is immutable. We're never going back and modifying any tables that we cooked before. And that's another very important point on separating readers from writers. If you're modifying the data that someone else reads, you got yourself some troubles, right? Especially with S3 and everything else. It's not a transactional storage, right? It's not RDBMS. So just book another version of it and take your time, right? It might take you hours to produce a whole new version of your data lake. And while you're doing this, people can still use your existing. Another important thing is that when you have this graph of different systems that communicate data to each other, and there's general data flow, right? So it flows. That's why we're calling it a pipeline. It's very important to say that this dependency tracking have to be enforced, right? So you have to know that this particular table is compatible with that particular table, and that so you can see how the crowdsourced data that you just received a couple of hours ago, how it affected the map, right? And see on every step what was the effect of this data coming in. And once you have this dependency tracking, you can see how different sources are compatible with each other, right? And for historical tables and logs, that's very important. So, because another thing, like if you just partition everything by time, you still got yourself into trouble, right? Because the changes that occurred on one system on one day might be propagated a couple of hours earlier to the next system, and there's going to be different partitions, so you get really joined by partitions. That's why the usage of proper clocks or artificial versions are very important, just in general. So like don't bind yourself to the clocks at all. So that's one of the main things that I wanted to share with you. And now some other very important clarifications that absolutely no text formats. People treat there all the way. They're trying to bring their own like little CSVs here and there, and if they're little, it's okay. If someone tries to upload a terabyte of CSV, maybe it's a problem. Use Parquet or ORC. It's a very nice format, again, like part of the Apache Foundation. Columnar formats, read optimized, very nice and sound with all the query engines that we're going to talk later. You can also use gzip and Snappy. Also comes out of the box with Spark. Right? If someone has questions, we can talk about the difference and one would use one versus the other. Another very, very, very important consideration, and that's where you actually still have this difference between reads and writes, is that how do you balance them, right? So if you work with Spark, you know that whenever you produce a table or anything, any data set, you can specify how many little files it's going to create on HDFS, S3, GCS, or whatever. And that actually has a big impact, right? Small files. Okay, you see that nice effect in PowerPoint. if you have too many files, slow reads, right? Like you have to download a lot of stuff, and actually the compression is overall low. And then if you have a very few files, then your write is super slow. You can provision this huge cluster that's going to load terabytes of data in memory and do processing very quickly. But if you're trying to write a one file after all, then it's going to be one executor, essentially one thread, just pushing this data to S3. That's going to be expensive, right? So balance out, and in Spark and latest versions, you can specify for Parquet. I think for RC that would work as well. How many rows you want for each file, right? Very nice feature. Then, if someone is interested, we can also talk more about different Spark tips and tricks. In general, I think like if you just start like experimenting with Spark, partition your data. That's the well, like I think every single talk, if you just Google on YouTube, any talks about Spark optimization, everyone talks about it. Partition your data. That's it. Like if you've done that, you're pretty much good. And all the other stuff is this nice thing. And again, if someone has questions, we can go back and talk more about that. Finally, how do you query this data, right? So we're using AWS Athena for one of our use cases. Google has BigQuery, similar idea, although AWS Athena is built on top of Presto, right? So if you work with Presto ever, or you have any issues with Athena, usually it's just one-to-one cooperation. It's very, very, very useful actually. Paid by service, just like Google JDBC drivers, you just connect, and it's very nice to produce on-demand reports and so on. Finally, another, like if you want to do something more fancy, you can use Apache Drill, and for example, grab some protocol data and mix it in with your main Parquet or ORC tables. That's going to be a bit more expensive, but again, you gotta do what you gotta do. Finally, you have Apache Spark and Zeppelin, right? That's just an amazing combo, pretty much for anything that you want to do with the data, and share your stuff in the notebook. And everyone likes notebooks. So another very interesting talking point to learn, especially like if you like building this data warehouse or data lake for real, is to really talk to your customers and make sure that you clearly understand what you're trying to build and like who's going to use it, right? So you should really ask, because that's where the cost gets generated. You have to find out like how data should be, how fresh should data really be, right? So should you update daily, hourly, every minute? Do you really update every minute? Are you like, is your customer willing to pay for these quick updates? And maybe that's not the right tool, you know. And then there is like some quick recipes how you can combine these things. So for our fast avenues, again, we've talked about like this producing a lot of small files. You can still do that. You can still like keep your small clusters with Spark that runs on a limited scope of data and produces these files every 15 minutes. It works just fine. And that will produce a lot of this massive amounts of files. And that's usually probably you want to do something like historical be on top of that and so on, because like what you're going to do afterwards, you can actually buffer up these files later on and compress them. And that's going to look like something like this, right? Once you combine them, you can have your latest, greatest partition on S3 or somewhere else in your file system that contains a lot of these small files that represent your up-to-date, like very, very fresh data. And at the end of every day, you just grab all these files, compress them as a one file, and write them and exchange. And that's the only place when you have to kind of make a exception for your immutable data case, right? Finally, data swamps, right? So if we have data lakes, at some point it will become a data swamp. So make sure, yeah, it's quite fast, yeah. So especially with immutable data, right? You have to clean up this from time to time. So again, archive or delete, you can glacier it if you're on the AWS, or you can try to find out some cheap storage for it. If you're producing certain tables that are not partitioned, make sure that you have some sort of a trading window strategy when you don't store the data for the last 3 years if you're really interested in by last 6 months or so, right? And another very important thing with the checkpoints, right? Whenever you, so how many of you are familiar with Hive Metastore or this? Okay, so that's one of the ways to basically that's what Athena provides you. That's what you can have with the Apache Spark and so on. It's Hive Metastore allows you to track all these files from your S3 or HDFS and also store a schema for them and work with them in a consistent way, right? So if Hive Metastore is not aware that you have new files or new table, it essentially doesn't exist for the end user, for the people who's going to query this data, right? So the important part is that Hive Metastore, like whatever you're going to use for it, Athena, GCS, they don't care if you put your data somewhere in the bucket, right? So you can really take your time producing these tables, and then once you're ready to make them available for the end customer, you just click and you do that. Another option, you can also use views for that. So if you really want to make these tables available as they come, maybe you just ask your customers to use views, and you might switch the view from one to another. So that's That's all for me. And back to Sneha.
So we covered a lot of ground here. So we went from 0 speed to kind of an optimal speed. But how do we ensure that we can run at an autopilot? Like how do we ensure that we can maintain this auto kind of speed without being too much effort? So that is where we can create some common things and abstract. So some of the things that we learned through this one was we can have a platform where we are doing a bring your own data. So you bring your own data, and provide some libraries. So you don't have to build a whole big platform, but one of the things you can do in order to share across the organizations is some of the common libraries. So you can go with some of the libraries for providing data compression, or you might have JSON representation, provide libraries for converting it into Parquet or Org. So you can provide these kinds of libraries to start off with before and try to leverage it across. So that's where you can create a platform by which some of these techniques which are learned over the time can be shared across. The same thing with built-in design patterns. How do you maintain history? How do you partition it by date? All of these kinds of techniques could be shared through either a platform or a library. And based on that, different teams can just bring their data in and have the cycle time for getting that data, raw data, into the data lake much more faster. Monitoring and alerting, with any system you need that. There are different solutions that could be used. We typically use Splunk with the result, Elastic, Logstash, and Kibana. So you can use these different techniques in order to kind of have alerts and logging so that you can see where in this whole big pipeline or where is the data kind of lagging, or is it compatible or not? Because the worst thing you can do is that you cannot have any compatible data. You can also provide some kind of Spark skeleton running in order to kind of have newer teams get onboarded so that they can have their data, use these libraries, and use a Spark skeleton in order to kind of load these into your data lake. So you can provide those transformers, skeleton stubs to different teams and provide that. So you're kind of internally building this platform so that the teams can adopt it. So in a nutshell, so what did we cover? We covered that there are 3 different parts. So in transformers, Spark has been one of our go-to in order to kind of do transforms. If you have data sources, multiple data sources, different teams, you can have these transforms and get that in a common alignment. There are some other transformers which could be used. In our case, for some of the unstructured ones, you can use some serverless configs. So you can go to cloud-based, you can use different techniques, but our go-to has been always majority Spark. In terms of storage, S3 has been one of the most, if you're in cloud, you can go with S3 for a file system where you can easily have the necessary availability, and you can use that as a data lake. HDFS can be used for data lake, in order for storage. So different techniques that can be used. Drill is on both the ends. So when you're talking about query engine and patterns, that's where your final end product is. You can get reports. You can use Tableau or any other BI software in order to get reports directly communicating. You can use Drill and query those reports. Zeppelin with notebooks is awesome for doing kind of ad hoc explorations. That combined with Spark helps. And that kind of summarizes our journey. So we started off, and this is where we ended up in order to build our data lake. So hope you got some insights on how we did this, and any questions? Yes.
So early on, you mentioned key point with data lake was just kind of importing data as is.
Yeah.
And then later on, kind of clarified by standardizing on a single format. So are you recommending that basically to do minimal transformation of the data such that like the data itself is still the same, the format is just normalized? Like
Yeah.
whereas a query house might actually do computation on the data and additional data.
Yeah, so the reason for that is that you might not know what insights you might get from the current data. So rather than kind of reducing the data set or kind of figuring out a schema or completely aggregating by doing joins prior and then loading in the data warehouse, get that data in and then do it. So there's a concept in data lake, like you have a landing kind of a thing where you put your data in, that's your list, and then you stage it and then you can aggregate it further. But the landing should be just get in all the data which you have, and then you can do further aggregations if needed.
One question. So yeah, I'm kind of wondering on what your views would be on kind of replicating data lakes. Just like a couple of years ago, I was working with a buddy of mine. I'm trying to develop some proof of concept data lake, and we were kind of taking heat from like it was Airbnb. You had like a gold and silver type of thing where you have one data lake be the immutable one, and another one be sort of read only that's more actually used for querying and stuff like that. How did you all solve that sort of thing?
So in our case, again, like data is immutable. No one writes to data lake except for, so like basically we got this main pipeline, right, that produces the map. And in our case, the data lake is not the product, right? It's an addition to the product at best, or like it allows you to compute KPIs and direct something. So that's why we're taking data out of the main pipeline and just like adding it to our data lake. But in general, like, what do you mean by like mutable data lake? That's one of the.
Aggregations that we run on it, so we keep, that's what I thought.
Yeah, I mean, we were looking at this as hopefully, well, back then it was a hopeful alternative to a bunch of crazy conference streams and Spark jobs. We were trying to make it a little more self-serve data scientists and that sort of thing. And the idea was we were trying to follow along the idea of, I think this was a couple years ago, so I might be misremembering some details, but from what I remember, there was such that like you had to be replicas so that if you were changing the data, you were only changing it to like the golden master data, essentially, such that like the downstream bits that people are actually reading from were updated in the program. Yeah, I think your immutable approach is probably a lot easier to actually deal with. I'm kind of wondering, like, did you explore this?
Yeah. So another thing that people do in Chicago as well is they keep like two kind of databases, right? So like with warehousing, that's one of the things that people do. Keep two clusters, mess with one, and leave the other one like alone, only for reads. Then once you're done messing with the second one, you switch them, right? So maybe that's one of the things. Like again, in our case, like once we publish data sets, like all our tables, we don't touch them anymore ever. So when we start putting the next version on the site, right, as the next subfolder or something, and then we switch to versions.
Yeah. One thing to add there is typically when you do with the data lake, you can always append more columns to it later on. So that way you're not doing any breaking changes. But if I got your question correctly, the other thing which we have done is that we get our raw data in, and then we have aggregators running on it. It could be another additional set of Spark, or maybe we're doing something. So we kind of keep them isolated and kind of maybe be it views, be it materialized views. We try to keep it isolated. And I believe in some cases we had to kind of keep the buckets different also through different bucket access policies, so that probably the raw data might not be in case of S3, you can also try it out with access control and market access policies.
Yeah, that's something online with those. It's kind of, they're very vaguely like CQRS, except for
Okay, so it scared me in beginning of the course. The same about random variety to the different packets. I mean, what made data different from the data dump is you have some metadata, so you know exactly which data exists where. Here,
Yes.
nowhere. Thank you. Here, at the end of the tool, you start talking about like metastore, which kind of brings this organization. So this becomes kind of too broad approach because in order for you to use kind of metastore, you have to define things first. And then you can run it. So what do you guys do for the whole metadata management thing so that you can find the buckets in the
Okay, so two things. A, our ETL jobs, the Spark jobs, they're actually writing the data, they know the schema perfectly, right? So they go and once all my tables are updated for my data set, right? The one that I want to keep consistent. Then I go to like right from the driver, I just go to HDMap, right, and switch the tables. Another thing you can do, for unstructured data and so on, you can just use crawlers, or you can like. There's another thing like good thing about Spark, and like for people who don't know, like you can define schema on the fly. So you can start reading the file and like discovering columns or like parsing JSON and say like, okay, you know what? I'm going to create this column because it's never been there. And then later on, Presto or whatever can combine multiple files and use like a superset of all columns that are defined in these files. Right? So you're not gonna like job is not gonna die just because in one file column exists, another doesn't exist.
So this brings to this question. The moment you add the columns, you broke your schema.
Yeah.
Kind of.
I mean, if people do a select star, then yeah, they might be broken because they're receiving more data. Yeah, but the important part, you don't delete columns. That's
Right. So your data has more columns that are defined in the kind of methods to work.
correct.
So you won't break anything, but you won't allow people to read the columns because like metastore doesn't know anything.
I mean, you update the table, yeah. So we have like the, like what's this thing for like
It's a way to do this.
like tables and schema management.
So this is so this brings to other things. The database tables are great for automatically reading the data, but if your master is trying to make sense of this data, you want to know the meaning. You want to know the meaning of both tables and individual elements of the tables. Otherwise, user can mean 50 different things to 50 different users. Sorry. So what do you guys do with this? So the problem is data discovery. If you have your jobs that are running, you probably don't care. If you're poor data scientist or data analyst, you need to know which data you want to look at. How do you find the tables?
My two cents is that A, documentation, and B, access, right? If you're receiving access to something, that means that there's people who provided this access and who's going to explain to you what it is. It's not that you're just like wandering around and trying to.
So the answer to number one, nobody can be important to pages of application. They get bored and full of sleep.
Right. One thing to add there is we also use, since we are in AWS, I'm sure there are other components in the cloud, we use the data catalog. So AWS data catalog and Bloom kind of shows us which, so that is what we use for data discovery. If there's any new tables which are added, definitely we follow a convention that the table names have to be, even for that base data, which is just this. You have a table name convention that if it's a multi-region, which region it's coming from, if it's related to some kind of content, you put the name in there, and version. So if there is a version change. And that's how we typically use for data discovery. But as Nikita pointed out, sometimes it turns that we should avoid making a swap because you might have too many discovery in your data catalog, too much to discover. So you have to keep your data catalog trained, is what I would say.
So you have to using Glue.
Yes.
How do you draw the line between what is a Spark transformation and what you'll use Glue for? So it looks like on your diagram you had only JSON data being read by Glue, maybe because that's the only format that bookmarks are supported on. Or can you speak more about that? How you create that?
Great question. My answer to that is you draw the line in the budget. So if you have engineering resources and you really like, if you think that it's better to use a well-defined Spark job, highly optimized to it, another awesome part of the Glue is just throwing money into and doing stuff, right? So it's very simple to use. It just basically goes, scans, like tries to figure out the schema. It has its own issues. We've been in situations when, yeah, okay, you see this. So, but still, like I think Glue is awesome if you want to start exploring the data, and then when you realize that, oh, you know what, you actually switch to another approach. And that we have one pipeline that used to be a Glue job, and now it's just moving to like a repeated pipeline.
And are you bookmarking jobs yourself in Spark with your Spark jobs, or like how does that work? So do you are you checkpointing jobs at certain stages, like keeping track of which data you've read, or are you reading all the data from the S3 bucket every time you run your transformation?
Okay, so yeah, if I'm working with one, so it depends. Like remember we had this slide with like 3 types of the tables, right? So when I can make this optimization like this, and just load data once, and then produce a bunch of other stuff with like a bunch of flavors, that's perfect. In other situations, for example, we're running tables that are like same cluster, same driver. It's just like our framework allows you to just define a new table and kind of scoop it into existing big job, right? That's another thing. Like yeah, if for example, I contributed bad code and I failed the whole cluster, we've been there, right? And then this cluster actually before that it produced 6 other tables that were totally fine. This table is not going to be overwritten. So next time this thing will retry, it's not going to overwrite this data. They're not going to be, however, published in Athena or in Hive, right? So that's our way of working.
And that's where the compatibility tracking helps, because then you know if certain things in the pipeline are lagging and they have not yet come through, and you expect that data to also flow through, then you can accordingly ensure that whatever trending you're doing or analysis you're doing, you're not having corrupted data or stale data included.
Yeah, I mean, do we want to continue having conversations in the sidebar just so we give folks time to travel and set up? But
yeah,
no, thank you so
Thank
much.
you. Good
I got a quick question. Is there a way
for me to plug in?
we have on board? I have an out. But so what if I need to?
I can throw it on a camera.
But if
There's a way for you to plug in either a standalone or
Oh.
maybe that might be easier.